Imagine floating in the vast, dark expanse of space. Suddenly, without warning, you're pulled towards an invisible force from which there is no escape. Space, as much as it holds the beauty of stars and galaxies, also harbors terrifying secrets that can haunt our most vivid nightmares. From black holes to rogue planets, the cosmos is filled with enigmatic features that challenge our perceptions and question our place in the universe. In this exploration, we will delve into some of the most frightening discoveries in space. By understanding these terrifying aspects, we can appreciate the delicate balance of existence and the sheer scale of the cosmos. This journey through space's most daunting discoveries is not only about fear, but also about awe and the endless quest for knowledge. Black holes, perhaps the most infamous of all cosmic phenomena, are regions in space where the pull of gravity is so strong that nothing, not even light, can escape from them. They are the ultimate endpoints of massive stars, and their existence challenges our basic understandings of physics. The thought of an object that can literally devour light is unsettling and sparks a primal fear of being consumed by darkness. The event horizon, the boundary around a black hole, marks the point of no return. Recent images captured by telescopes like the Event Horizon Telescope have given us a glimpse into these dark abysses, yet much about them remains a mystery. For humanity, black holes represent not just a scientific interest, but a potential threat. Theoretical discussions about rogue black holes drifting through space and passing near our solar system are the stuff of nightmares. They represent a limit to human knowledge and exploration, a boundary beyond which no observer can return to tell the tale. Rogue planets, also known as interstellar planets, are not bound by any star and drift freely through the galaxy. These celestial nomads travel through the darkness of space unseen and undetected, until they possibly collide with other celestial bodies. The idea of planets roaming freely in space, potentially causing chaos, is a disturbing thought. These planets are mysterious because they do not emit light and are difficult to detect. They are like phantoms of the cosmos, lurking in the shadows, only observable by the gravitational effects they have on other celestial bodies, or through the rare transit in front of distant stars. Their unpredictable paths pose a potential threat to any solar system they pass through. Rogue planets are fascinating not just for their elusive nature but for what they represent, the chaotic and dynamic nature of our universe. They might harbor life in subsurface oceans heated by radioactive decay rather than sunlight, suggesting new possibilities for life beyond our conventional understanding. Gamma ray bursts, GRBs, are the most powerful explosions known in the universe, emitting more energy in a few seconds than the sun will in its entire lifetime. They are cosmic events of extreme violence, believed to result from the collapse of massive stars or the merging of neutron stars. The destructive power of GRBs is unimaginable, and if directed towards Earth could potentially trigger a mass extinction. These bursts are terrifying not only because of their power, but also because of their unpredictability and invisibility. They travel across the cosmos at the speed of light and could strike without warning. The Earth's atmosphere shields us from their deadly radiation, but a close enough burst could strip away our protective atmospheric layer, leading to catastrophic consequences. Despite their potential threat, GRBs illuminate the workings of the universe in ways no other phenomena can. Supernovae are among the most spectacular and frightening events in the universe. These colossal explosions mark the death throes of massive stars, outshining entire galaxies and releasing vast amounts of energy. The spectacle of a supernova is a reminder of the volatile and transient nature of the cosmos. The shockwaves and materials ejected from these explosions can trigger the formation of new stars and planets. However, the force of these explosions is also capable of wreaking havoc on nearby planetary systems, including potentially our own. The fear associated with supernovae is not just their destructive potential, but also the profound reminder that the universe is governed by cycles of creation and destruction far beyond human control. Moreover, the elements necessary for life, such as carbon and iron, are forged in the heart of dying stars and spread through these explosive events. In a poetic sense, we are made of star stuff, born from the cataclysmic forces that we fear, tying our very existence to these cosmic explosions. Dark matter and dark energy are two of the most mysterious and dominant components of the universe. yet they remain invisible and undetectable by conventional means. Dark matter, which makes up about 27% of the universe, does not emit, absorb, or reflect light. It reveals itself only through its gravitational effects on visible matter. Dark energy, making up about 68% of the universe, is even more enigmatic, driving the accelerated expansion of the universe against the pull of gravity. The existence of these dark components challenges our understanding of physics and the fundamental composition of the universe. They represent vast quantities of matter and energy that are completely unknown to us, hidden in plain sight. The idea that we are blind to most of the universe is not only humbling but also somewhat unsettling. The implications of dark matter are particularly profound for the fate of the universe. Neutron stars are the remnants of massive stars that have undergone a supernova explosion. They are incredibly dense, with a mass greater than that of the Sun packed into a sphere only about 20 kilometers in diameter. The density of a neutron star is so extreme that a sugar cube-sized amount of material from one would weigh about 1 billion tons on Earth. The extreme conditions on neutron stars defy ordinary understanding. Their surface gravity is billions of times stronger than Earth's, and they have magnetic fields millions of times more powerful than any created by humans. These stars are not just extreme, they are the ultimate expression of the laws of physics pushed to their limits. One of the most fascinating and terrifying aspects of neutron stars is their potential to form pulsars. Pulsars are neutron stars that emit beams of radiation that sweep through space as the star rotates. The Great Attractor is a gravitational anomaly located about 250 million light-years away, drawing in galaxies, including our own Milky Way, at astonishing speeds. This massive, unseen force suggests the presence of something incredibly large and dense, yet it remains largely invisible, obscured by the plane of the Milky Way. The concept of the Great Attractor is fascinating and somewhat unnerving. It raises questions about what lies at the center of this massive gravitational pull. Is it a huge concentration of dark matter, an enormous supercluster of galaxies, or something entirely unknown? The mystery of the Great Attractor highlights how much remains to be discovered about our universe. The pull of the Great Attractor affects not just galaxies, but the very fabric of the cosmos, influencing the motion of millions of stars and potentially altering the structure of the universe itself. While not as cosmically vast as black holes or supernovae, space debris represents a more immediate and practical danger. Thousands of pieces of defunct satellites, spent rocket stages, and other fragments orbit Earth at incredibly high speeds, posing risks to active satellites, the International Space Station, and future manned space missions. The issue of space debris is a direct consequence of human activity in space and illustrates the unintended side effects of space exploration. Each collision or additional piece of debris increases the potential for further collisions, a cascade effect known as the Kessler syndrome. This scenario could render regions of space unusable for decades, hindering not only scientific advancement but also our everyday reliance on satellite technology. Managing space debris requires international cooperation and innovative solutions. The challenge of space debris is not just about safeguarding our space infrastructure but also about being responsible stewards of space as a shared global resource. The terrifying discoveries in space challenge our understanding of the cosmos and our place within it. Black holes, rogue planets, and gamma-ray bursts are just a few examples of the myriad phenomena that make the universe a vast, mysterious, and sometimes frightening place. These discoveries not only expand our knowledge but also expose us to the inherent dangers of the cosmic ocean. Reflecting on these phenomena, we realize how small and fragile our place in the universe truly is. The vast forces at play in the cosmos can inspire fear, awe, and a profound sense of humility. However, this recognition should not discourage us but rather motivate us to learn more and to approach the universe with respect, curiosity, and a readiness to embrace the unknown. By embracing the vastness and the mysteries of space, we can better appreciate the intricacies of our own existence and the remarkable resilience of the human spirit in its quest to explore and understand the infinite.